Now let's talk about internal or relative coordinates. But to define internal relative coordinates, okay, we define it in terms of the actual coordinates of two particles. So let's say particle 1 is at x1, y1, z1. Particle 2 is x2, y2, z2. We define the internal coordinates or the relative coordinates as the coordinates of particle 2 if we were to set our origin at particle 1. In other words, if this is particle 1 and that's particle 2, it doesn't matter exactly where 1 is. We're going to set our origin there. Okay? We're going to set our origin there. And we locate particle 2 in reference to particle 1. So the relative or the internal coordinate system is a movable coordinate system. The origin moves wherever particle 1 is. Okay? So our relative coordinate would be just the difference between x2 and x1. Okay? So for example, let's just do it in one dimension. Let's say particle 1 is over here. Okay? And particle number 2 is over here. Let's say this is at 1 nanometer and this is at 3 nanometers, let's say. Okay? So what's the relative coordinate of particle 2? What's the relative coordinate in this case? Where is particle 2 if we set our origin at particle 1? It's 3 nanometers minus 1 nanometer. It's going to be 2 nanometers. It's like saying I'm going to make this 0, so this is going to be 2. Okay? So that's what your relative coordinates are. So y will just be little y will just be y2 minus y1, and little z will just be z2 minus z1.